This question gives us this function right here and says for this function, there's four important intervals and they're breaking them up with A, B, and C. And they're in order, notice, it goes negative infinity to A to B, B to C, C to infinity. So we got to find them. There's the answers. How did they get them? Well, they say first off that they're critical numbers. So you know how we find critical numbers? We take the derivative. So I'm going to take the derivative of this function right here. 8 derivative of 8x is 8. Derivative of this part, the negative 1 comes down. Minus 2x to the minus 2, subtract 1 from the power. There's the derivative, and we set it equal to 0. That's how we find critical numbers, as we take the derivative, set equal to 0. So now how do we solve this? Well, I'm going to bump this to the other side. So we'll get 8 is positive 2x to the minus 2. And I'm going to divide by 2. Negative x to the minus 2 is 4. And then that means 1 over x to the positive 2. Remember that? Remember how a negative power means it jumps to the bottom? And then what are we going to do to solve this? Well, I'm going to suggest let's just put this over 1 and go diagonal, diagonal. So we get 4x squared is 1 times 1. So 4x squared is 1. Divide by 4. So x squared is 1/4. And then we root it. But remember when you put a roof on the house, up and down the ladder, don't forget the plus or minus. And then you get plus minus the square root of 1 is 1, square root of 4 is 2. So plus or minus a half. Plus or minus a half. Now, um, so those are the critical numbers. Now the other one says function is not defined at B. So this is the A, the negative a half and positive a half. That's the A and the C, right? It says A and C are critical numbers. So that's A and C, negative a half and positive a half. Okay, I made right A. It says A right here. Negative half, positive half, C right there. But how do we find B? It's not defined at B. Okay, so let's write it. Let's write the function right here. So the original function, 8x plus, forgot the x there, huh? 8x plus 2x minus 1. What makes it undefined? Well, undefined, not defined at b, that always means that the denominator equals 0. So do you see the denominator of this function is 8x plus 2 over x to the positive 1. Remember, again, negative powers jump to the bottom. So basically, whenever this denominator is 0, that's easy. That's just when x is 0. So that's what goes right here. The b is 0. When x is 0, when you plug in x equals 0 to this function, the 8 is fine. 8 times 0, that's just 0, no problem. But you're going to put in a 0 there because that negative 1 power really means that x is in the denominator. And that's 2 over 0. That's undefined. You can't divide by 0. That's infinity. It's undefined. It's important to know that. So there we go. So there's our A, B, and C. And so now we're going to use that to break up our intervals and find out where this function is increasing and decreasing. What tells us that? Well, f prime. If f prime is positive, it's increasing. And if f prime is negative, the function's decreasing. So we got to find out where's f prime positive or negative. So then we're going to need to do a little number line. I think it'll come on down here. Got a little bit more room. And going to break this thing up. And we're going to put 0 in the middle. And so smaller, this will be x equals 0. And then over here, I'm going to do, wait, no, click that along. Just there. I have a reason. I'll show you why. Second, this is x is negative 0.5. This is x is positive 0.5, right? This is the A, the B, and the C. Okay. And they want us to, they said, break it up with, A to B, B to C, C to infinity. So, right, this is, so that's these four intervals. This one goes from, this is positive infinity over, and the rest is a number line. So this goes from negative infinity to A to B, B to C, C to infinity. Okay, that's those intervals. And we want to check the first derivative. What's first derivative? Right here. 8 minus 2x to the minus 2. So 8 minus 2x minus 2. That's the what we're going to plug in. We're going to plug in f prime, find f prime in each of these sections. What are we going to plug in? Well, we need a checkpoint. We need to check something here. So I'm going to check x equals negative 1. That's something that's left of negative 0.5. Right here, I'm going to do negative 0.25. I'm going to check that. Right here, I'm going to check x is positive 0.25, right? Because 25 cents is between 0 and 50 cents, right? This is a 0.50, 0.5, right? This is a 0.5. So check that. That'll be that interval. And over here, I'll just check something like positive 1, because that's bigger than 0.5. All right. So I'm going to take that negative 1, negative 1, pop it in there. So I'm going to go to that function, plug in negative 1, see what I get. So, oops, it's not that one, it's this one. There it is. I've already typed it into decimal, plugged in negative 1, got 6. So it equals positive 6. Now I'm going to plug in negative 0.25. Same function, negative 0.25. There we go. Got negative 24. Negative 24. Now I'm going to plug in positive 0.25. Regular 0.5. Negative 24 again. Same-o, same-o. And then positive 1. Positive 1, get 6. Positive 6. Okay. So this means increasing going up because derivative is positive, decreasing going down, derivative is negative, decreasing going down, negative, increasing going up, derivative positive. So we get increasing, decreasing, decreasing, increasing. So, yep, increasing, decreasing, decreasing, increasing. Now, last thing last.
Mr. Harry, I'm done.
So last thing last here is we have to do the inflection points. So how do we do the inflection points? Well, or I'm sorry, the concavity. So the concavity is second derivative, right? Second derivative positive, that's concave up. And if the second derivative is negative, that's concave down. And check concavity, but notice we're only checking around B, just left of B and right of B. So coming down here, that's why I made this a bigger divide, the B. Here, let me separate this. So the B continues to be a dividing point. I'll scribble it in there. Oh, that didn't work, huh? So here we go. The B continues to be a big dividing point. So I'm just going to plug, now I'm going to plug into the second derivative. Let me find what is the second derivative. So I got to find it. So what was the first? Here was the first derivative. I got to take another derivative. So the second derivative, take right here. This is the first derivative. Take another derivative. That just goes to 0. This minus 2 comes down. Minus 2 times minus 2 is plus 4. X to the minus 3, subtract 1 from the power. There we go. There's the second derivative. And now I'm going to check it. You could do the negative 1. You could do the negative point. Anything on the left side here. I'll just do the negative 1. That looks easy. I'll just plug that in. See what I get. So in anything left of 0, and then we're going to plug in something right of 0 and get f double prime over here. I'll probably just do positive 1. Just plug in positive 1. All right. So let's start with this one, the negative 1 to the negative 3. I've actually done it right there. Comes out negative 4. Comes out negative 4. Okay, and now let's do positive 1, make positive 1. And there it is, positive 4. Positive. So that means concave down in the first section, and this is concave up in the section. So down and then up, and down and then up. It's exactly what we get. And so there we go.